request Dr. Brijesh Thakkar for the presentation.
Shall I begin?
Yes.
Good afternoon. It's a hot environment. Let me try to cool it a bit. So I'm Brijesh from Hyderabad, and these are my disclosures. This study is actually funded by Ali Prasad Eye Hospital funding mechanisms. The acknowledgements are right there. So why am I looking for alternative avenues to stop diabetic retinopathy? The fact being that there is metabolic memory which is going on and on in our body. The census in our country showing that most of the Indians don't know that they have diabetes, and if they know they have diabetes, it's not controlled. The fact that we have only invasive therapy for diabetic retinopathy, the fact that we do not have a secondary level prevention for diabetic retinopathy, and we still have a high rate of sight-threatening diabetic retinopathy in Asia. After everything done, we need to look for something else. And why I chose microbiome, the fact being that it is something which can be offered as a non-invasive therapy to our patients. So why to look at the gut? So we started looking at the gut. We looked, if you can see my cursor, we looked at rats, we looked at humans. We drew these heat maps. We showed that the people with diabetic retinopathy, they seem to cluster together. They seem to come together. They have a different kind of microbiome in their gut as compared to healthy controls or diabetic people with DM without DR. But what is the link? So here I took the help of my fellows and we started looking at what are the possible mechanisms. Why the gut? Why the eye? How come they are linked together? We charted out these 6-7 mechanisms. We charted out the detailed biomolecular mechanisms, and we started believing that yes, it is possible. But if it is possible, what is there inside the eye? Which is a research question that I come up with here today. And we started looking whether there is an evidence of microbiome there inside the eye as well. So this was a pilot study in itself, not done before, and we included people who were undergoing cataract surgery, and we took out their aqueous. We ruled out signs of open globe injury, signs of intravitreal injections, anything which could have introduced a microbiome inside the eye. We tried to exclude it. We screened 22 people. We included 17, and we analyzed 12 people as we lost some of the samples which were not amenable to laboratory analysis. We balanced out these people in terms of their diet using the help of United Kingdom Diabetes Mellitus Questionnaire. We put this across the laboratory. We took out the microbiome DNA. We removed the human DNA. We did amplification of the DNA of the microbiome. Then we sequenced it using techniques known as next generation sequencing. And then we finally came out with the fact that these are the microorganisms which are actually present. After that, for a quality check, we did negative controls. We made a very rigorous sample collection. We drew rarefaction curves. This is a rarefaction curve, which is very typical of any microbiome, which tells you that the study was done with good amount of quality. So these are the results. So what are the results? These 4 people with DR, they came together again. This red thing shows that these particular organisms over here were actually absent in DR, whereas people with healthy control and DM, they had some kind of a mixed result. So we started looking at each and every relative abundance of each and every organism differently. So this table shows healthy control versus DM. This table shows healthy control versus DR. This one shows DM versus DR. Look at the amount of organisms which were different in DM versus DR. So this is what told us that relative abundance in DR has a very wide gap as compared to DM and healthy control. And we realized that all these bacteria which were seemingly absent were actually anti-inflammatory in nature. This anti-inflammatory in nature is accounted for by the databases which are available for any microbe all over the world. Any study has limitations. This world is not perfect. This room is definitely not perfect for the environment, but our study had limitations too. It was done hand in hand with COVID. We could not account for age and alcohol intake. We could stop only at metataxonomy. There are better ways of doing sequencing. We had a low sample size. Again, pilot study is always right and always wrong, but we did have some strengths also. These strengths were the rigor which went in sampling techniques, so much so that the patient who underwent cataract surgery were again seen by me just to make sure what amount of retinopathy they had. And then only a single person was involved in all kind of procedures that were done in this study. And with this, finally we concluded that all eyes, including all of us over here, the judges, the people managing the AV systems, we have some kind of a microbiome there inside our eye. The aqueous humor dysbiosis is distinct in gut microbiome as compared to the aqueous microbiome, and the aqueous humor of people with DR has some unique genera. Where this leads us? This led us to beginning up a pan-India study across 17 states of India with a feasibility pilot sample size of 500, which is currently going on. We have reached 350 samples right now, and we are looking towards finding both biomarkers as well as a preliminary therapy towards stopping diabetic retinopathy. Thank you for the patient hearing in the hot environment.
Thank you for your nice presentation. Do you want to publish it?
It is published. I showed in the second slide, I think.
Okay. Sorry, I missed it.
Yeah, it's published.
Then you can present in the
No, I cannot take award. I can present.
You can present.
Okay,
I just wanted to share my data.
that's okay.
Then the preoperative antibiotic use for cataract surgery, will it affect the microbiome?
So we do not use preoperative antibiotics. We just use topical betadine just before the cataract surgery. That is the protocol, and nothing else, sir.
You said there was a different microbiome in DR cases. So, which could probably be inflammatory. So
In DR, it was anti-inflammatory, sir.
right.
The people who had DR, they had loss of anti-inflammatory microorganisms.
Correct. So, how do you say that those were anti-inflammatory?
Yeah, so this is from the database of the organism, which is here, there, everywhere, but not inside the eye. The function of all the microorganisms inside the eye is never tested. So to do that, we are doing this next study. So we are looking for, RNA transcriptomics. We are looking for metabolites inside the eye to say that, no, we found this. But just to say that my hair is over here does not mean that I committed the murder. There has to be some evidence between my hair and the murder. So we are trying to look for those things.
So this comes good, I think, with something like probiotics, something
Yes, sir.
you can prevent diabetic retinopathy.
Yes, sir. More than that, if we feed our mothers with good things, the 3 generations next may not have diabetic retinopathy.
Thank you.
Thank you.
Thank you so much.
Really, it's a nice presentation. Hats off to you.
It's a very nice and very informative.